We are looking at circles, arcs, and sectors. But first, what is a circle? A circle is a description or a locus of points which are equidistant from a given point. That's what a circle simply is. If I have a point, normally described as the center of the circle, the points there, and we now have a set of points all described around this point, and all of them being of equal distance from the point that is the central point. That gives us of what we call a circle. Now, the area of a circle and its circumference are popular things we know, as you can see right on the screen. The circumference of a circle is just another word for the perimeter of a circle. Remember, we've said in earlier clips that the perimeter of an object is the total boundary length. Likewise, the circumference of a circle represents the entire boundary length of a circle and is always calculated as 2 pi r, 2 pi times the radius, and the area of a circle is popularly given as pi radius square. Our major focus will be arcs and sectors. What is an arc and what is a sector? As we've said, the circumference of a circle is given as 2 pi r. Let's keep that at the back of our mind, which is what the perimeter of the circle, the total boundary length of a circle, and then the area is what? Pi r square. What then is a sector of a circle? A sector of a circle is just a fractional part of the circle. We all know that a circle covers 360 degrees. If we cut out part of that circle, having some angle theta out of the 360, and then it is bound on both sides with the radius and the arc AB, as you can see on the screen. That shape that looks like a pizza is what we call a sector. Let's call this O. So I can say that this is sector AOB. So as we have on the screen here, we say a sector is a fractional part of a circle taking out some angle theta of the 360, which is of the complete circle. It is bound by 2 radii and an arc. And then what is an arc? An arc is something like AB, as you can see, and also it is a fractional part of the perimeter of a circle. The perimeter of the circle is the entire circumference. When you just cut out some section of it, which subtends an angle theta at the center, that length or that section that has not been cut off is called an arc. So here we have arc AB and we have sector AOB. Both of them taking out theta out of the 360 degrees of the complete circle. That defines what the arc is and the sector. The arc is related to the perimeter, that is the circumference. Since the circumference of a circle is 2 pi r, and the circle actually covers a total of 360 degrees, the arc AB, as we have here, is just a fraction of that circumference, and it's taking out theta out of the 360. So that defines the fraction of the circumference. So it is taking out theta over 360 of that circumference 2 pi r. And that gives us this formula that the length of the arc is what? Theta over 360 times 2 pi r. While the area of the sector AOB is taking out again a fraction of the area of the circle. The entire circle occupies 360 degrees, while the sector is taking out just theta out of the 360. So the area of the sector is therefore that fractional part, which is this, the fraction of the entire circle. So the area of a sector is theta over 360 times pi r square, or you can say theta over 360 times the area of the circle. Let's see how we can apply this information in treating this problem. Here we have an object. We have a semicircle, or should I say two semicircles. We have an outer semicircle and then an inner semicircle, sort of half of a ring. We are told to find the area of the shaded portion in the figure above, that is the portion that is shaded blue. What is the area of this shaded portion? That is this portion here, the portion shaded blue. First and foremost, if we look at this shape, it looks like a semicircle. The outer one gives us one semicircle, and the inner one gives us another semicircle. Of course, a semicircle, you may want to look at it as a sector, but this is a complete half of a circle. This is subtending an angle of 180. So I'm going to take what? In order to find the area of the shaded portion, we're going to find the area of the larger semicircle and then the area of the inner semicircle and subtract. So we have an area of shaded portion is area of large semicircle minus area of small semicircle. And the large semicircle is pi r square. The small one is also pi r square. Both of them divided by 2. But the radius for the large one is given as capital R. The entire diameter is 22 from there to this point. Therefore, our capital R will be half of that from this point to that end, which means our capital R is what? 22 over 2. That gives us 11. That's the radius of the large semicircle. Now, the inner semicircle has a diameter of 6, and half of that will serve as its radius. So, the inner semicircle will have a radius of 6 divided by 2. And that should give us 3. So with that, we can substitute. That's it there. Capital R is 11 centimeters. Small r is 3 centimeters. Substituting this into the expression, we have here that the area of the shaded portion, as we have said, is what? Area of the large semicircle, pi r squared, that's 11 times 11, then divided by 2. And then also here we have pi r squared, 3 times 3, and then divided by 2. That's for the small semicircle. And then computing this, we have the large one as 2,662 divided by 14. And then the small is 108 divided by 14. Computing these, we arrived at the area of the shaded portion is 182.43 centimeter square. That wasn't too difficult. Number 2, we are told to find the perimeter of the above figure. Perimeter is what? Total boundary length. How do we obtain the perimeter of this shape? The perimeter will include this length, which is the circumference of the semicircle. That is, find the circumference of a circle and divide by 2. And likewise this is half of a circle also. So we'll find the circumference of the inner semicircle and then out of that of the outer one, and then add this part to it, these two parts. So that will give us the total boundary length. That's what we are looking for. The total boundary length. That's the perimeter. So I'm going to use 2 pi big R divided by 2. That's the circumference of the larger semicircle. And then we apply 2 pi small r divided by 2 for the inner one. And then we add these two lengths, this and this. Now, how do we get those two lengths? From this point to this point is 22. If I subtract 6 from it, that will give me 16, which means this is 8 and this is 8. We add both of that and then we obtain the perimeter of the figure. Let's see how that is done. So the perimeter is what? 2 pi capital R over 2. That's for the outer ring. Plus 2 pi small r over 2. That's for the inner part. And then plus 8 plus 8. The rest is history. We just substitute 22 over 7. Of course, if you look at this very well, you will agree that this 2 will take care of this 2. This 2 can take care of this 2. So we just have pi 22 over 7 and r 11. And here we have also pi 22 over 7 and then r 3. And then we add the 2 8s. And of course, proceeding, we have for the first one 242 over 7. The second one 66 over 7, which is 3 times 22. And then plus 16, your 8 and 8. And that gives us the perimeter to be approximately 60 centimeters. Let's proceed. Here we have a sector AOB. We're asked to use the figure above to answer the following questions. Find the area of the sector AOB. What is the length of arc AB? And calculate the perimeter of sector AOB. Area of sector, we have agreed that the sector is a fraction of a circle. So the area of a sector is what? That fraction, theta, out of what? 360 times the area of the circle itself, pi r square. And in this case, the sector is taking out 120 degrees out of the 360. And then pi, which is 22 over 7, times 4, the radius square. Now compute this. That's it there. We compute that, we have 16.76 centimeter square. Similarly, for the length of the arc again, as we have said, is just a fraction of the circumference of the circle. So length of arc, that is AB, the length of that arc will be theta all over 360. That's a fraction of the circumference 2 pi r. And that is what? 120 divided by 360 times 2 times 22 over 7 times the radius 4. Computing this, that's it there. Theta over 360 times 2 pi r. And then we substitute the values and then we obtain the length of the arc as 38 centimeters. Next, we are asked to find the perimeter. That shouldn't be anything difficult. What is perimeter? Total boundary length. Right? Total boundary length. That's the perimeter. Let's change the color of my marker a bit. Okay. The total boundary length will be from O down to A, down this curve, AB, and then back there. So you'll agree with me that the total boundary length we are looking for will be this 4 plus this 4 plus the length of the arc AB. We have obtained the length of the arc as 8.38. So we are simply going to add 4, one of the radius, and then 4, the other one. And that gives us the perimeter of sector AOB. Let's see how that plays out. Perimeter is length of arc AB, yes, plus OE plus OB. And that's 8.38 centimeters, which we have calculated already, plus 4 centimeters, plus 4 centimeters. And that gives us the perimeter as what? 16.38 centimeters. Yes, with this we have touched all the plane shapes we mentioned at the commencement of the topic, mensuration of plane shapes. We will take one more video clip in which we will see how some of these plane shapes can be combined to form composite shapes. Thank you.